Daily space marvels, the cosmos inside, exploring the stars from morning to night.
Welcome back to Daily Space Marvels. Today, we're diving into one of Earth's most fascinating defenses against the dangers of space, the Van Allen belts. These remarkable regions of charged particles form a protective barrier around our planet, safeguarding us from harmful solar radiation and cosmic rays. But what exactly are these belts, and how do they function? Join us as we venture into the Van Allen belts, Earth's own set of cosmic armor. Before we begin, don't forget to like, subscribe, and activate notifications to stay updated with more amazing space facts. The Van Allen belts were discovered in 1958 by Dr. James Van Allen, a pioneering physicist whose work revolutionized our understanding of space. These belts are essentially donut-shaped regions of high-energy particles trapped by Earth's magnetic field. There are two main belts, the inner belt, primarily composed of protons, and the outer belt, which consists mainly of electrons. These belts extend thousands of kilometers into space and play a crucial role in protecting life on Earth. Dr. Van Allen's discovery was groundbreaking, highlighting the complex interactions between the Sun and our planet, and laying the foundation for future space exploration and radiation protection. The discovery of these radiation belts was a key milestone in space science, leading to numerous studies and missions aimed at exploring and understanding these phenomena. The findings underscored the importance of radiation protection for both astronauts and satellites. The formation of the Van Allen belts hinges on Earth's magnetic field, which acts like a giant shield. This magnetic field is generated by the movement of molten iron within our planet's core, creating a complex magnetic environment. When charged particles from the Sun, known as the solar wind, encounter this magnetic field, they are deflected and trapped within these belts. The inner belt, closer to Earth, contains high-energy protons primarily from cosmic ray interactions, while the outer belt is dominated by electrons from the solar wind. Without this magnetic shield, life on Earth would be exposed to intense radiation, making our planet a much more hostile place. The Earth's magnetic field deflects these particles, trapping many of them in the Van Allen belts. This deflection mechanism protects the Earth's surface from the full brunt of solar and cosmic radiation. One of the most fascinating aspects of the Van Allen belts is their dynamic nature. These belts are not static, they change in response to solar activity and other space weather phenomena. During periods of high solar activity, such as solar flares or coronal mass ejections, the belts can swell and intensify, posing a greater risk to satellites and astronauts. Conversely, during quieter periods, the belts can contract. Understanding these variations is crucial for predicting space weather and protecting space-based assets. The belts can expand, contract, and even form additional temporary belts under certain conditions. The Van Allen belts have a significant impact on space exploration. Satellites and spacecraft must navigate these regions carefully to avoid damage from the high-energy particles. Engineers design satellites with shielding to protect sensitive electronics from radiation. But prolonged exposure can still be harmful. For example, the electronics on satellites can degrade over time due to radiation exposure, potentially shortening their operational life. To mitigate these risks, space agencies such as NASA and ESA have developed strategies to minimize the time spent in the belts. This includes choosing specific flight paths that avoid the most intense regions of radiation. For missions that must pass through the belts, such as those traveling to the Moon or beyond, additional shielding and protective measures are implemented to safeguard both equipment and astronauts. These measures are essential for the success and safety of space missions. In addition to shielding and flight path optimization, another strategy being explored is the use of materials and technologies that can better withstand radiation. Researchers are investigating advanced materials that can provide more effective protection for spacecraft and their occupants. These materials could be used to construct more robust spacecraft hulls and shielding components, reducing the overall exposure to harmful radiation. Additionally, innovations in autonomous systems and artificial intelligence are being leveraged to enhance the resilience of space missions. These technologies can help spacecraft autonomously detect and respond to changes in the radiation environment, optimizing their operations to minimize risks. Another fascinating phenomenon associated with the Van Allen belts is the auroras, those stunning light displays in the polar regions. When particles from the belts collide with Earth's atmosphere, they can excite atmospheric gases, causing them to emit light. This process creates the beautiful auroras, also known as the northern and southern lights. The most common colors seen in auroras are green and red, which are produced by oxygen, and blue and purple, which are produced by nitrogen. Auroras are more than just a beautiful natural phenomenon. They are a visible reminder of the dynamic interactions between Earth's magnetic field and the solar wind. Studying auroras helps scientists understand the processes occurring in the magnetosphere and the Van Allen belts. These studies also provide insights into space weather, which can affect satellite operations, communication systems, and power grids on Earth. Numerous scientific missions have been dedicated to studying auroras, using both ground-based observations and satellite instruments to capture detailed data. Despite their protective role, the Van Allen belts also pose challenges for future space missions, especially those venturing beyond Earth's orbit. As we look towards missions to the Moon, Mars, and beyond, understanding and mitigating the risks posed by these belts is essential. These missions must pass through the belts, exposing spacecraft and astronauts to higher levels of radiation. This exposure presents significant challenges for mission planning and safety. To address these challenges, scientists and engineers are developing advanced shielding technologies and optimized flight paths. For example, NASA's Artemis program, which aims to return humans to the Moon, includes plans for enhanced radiation protection for both astronauts and spacecraft. These efforts are crucial for ensuring the safety and success of long-duration space missions. Another aspect of preparing for future missions involves developing better predictive models of space weather. Accurate predictions of solar activity and the resulting changes in the Van Allen belts are essential for mission planning and operational decision-making. Into the Van Allen belts is vital for improving our understanding of these complex regions. Various missions have been launched to study the belts, including NASA's Van Allen probes, which were launched in 2012. These probes have provided valuable data on the belt's structure, composition, and dynamics. The information gathered by these missions helps scientists develop better models of space weather and radiation environments. In addition to satellite missions, ground-based observations and theoretical studies contribute to our knowledge of the belts. Researchers use computer simulations to model the interactions between the solar wind, Earth's magnetic field, and the trapped particles. These models are essential for predicting space weather and its impacts on space and ground-based systems. Educational initiatives and public outreach efforts are also important components of research on the Van Allen belts. By educating the public about the significance of these radiation belts and their role in protecting our planet, scientists can foster a greater appreciation for space science and its applications. In conclusion, the Van Allen belts are a crucial component of Earth's defense system against the harsh realities of space. They shield us from harmful radiation, contribute to beautiful auroras, and present challenges for space exploration. As we continue to study and understand these belts, we enhance our ability to protect our planet and safely explore the cosmos. Thanks for joining us on this journey through the Van Allen belts. If you enjoyed this video, be sure to like, subscribe, and activate notifications to stay updated with more amazing space facts. Until next time, keep marveling at the wonders of space.